Hey everyone. Today we're going to be talking about managing your SQLite databases using the Room Persistence Library. Specifically, I want to go over the different types of database relationships you can have in your Android applications. For each one, we'll understand when to use it and how to enforce and query these relationships using Room. You don't need to be an expert, but I do recommend understanding some of the basics, so I'll put a link to the Room documentation in the description. Before we start talking about the different types of relationships, it's important to understand at a fundamental level why we need them. So we're going to start by demonstrating how to create an entity in Room and understanding the limitations we face with those entities. Let's create an entity called student. This entity is going to have three properties: a primary key, which is a student ID that we'll make a long, a first name, which is a string, and a last name, which is also a string. Now Room will be able to support this because all of these map to valid SQLite data types. But if we try to make this more complicated and create an address with a street name and a street number, and try to add this address class onto our student entity, Room isn't going to know how to save this because address is not a valid SQLite data type. And that's the baseline of what we'll be working with today. SQLite can store all of the basic data types inside of its columns, but it doesn't get any more complex than that. Unfortunately, our applications need to store complex data. We need to keep track of students and their addresses and the classes that they're taking. Now, the right solution to this varies on the type of data that we're trying to store. The first approach we're going to look at is embedded properties. So let's go back to the student entity that we just had trouble saving thanks to its address property. The quick solution to being unable to save the address property is to use the embedded annotation. What this will do is take each of the properties from address, the street name and street number, and add those as columns onto the student table. We can demonstrate this even more clearly by adding a prefix property in this annotation and seeing that address underscore is added to each of these column names within the student table. The embedded annotation is great. It gives us a short, quick, one-line solution to storing more complicated data within our database tables. The drawbacks of using embedded properties comes when we begin to explore this concept of data integrity. Since the two properties from address just became additional fields within our student table, we don't have any way to enforce that, say, two students share the same reference to an address. This opens us up to a concern called an update anomaly. Let's consider two students, Adam and John, who are meant to live at the same address, and we insert them into our table that way. If I go in and update only Adam's record to change his address, they are now pointing at two different addresses, and I can look at the database and have no idea which one is right. Now, if this data integrity isn't a big concern for you, and you were just looking for a way to better structure your Room entities, the embedded properties is the way to go. If you're trying to do something where you need to enforce a relationship between one entity and another, we need to do so at the database level. If we are concerned about data integrity and sharing pieces of information, often the right thing to do is take that new information, put it inside a new entity, and create a link between that entity and the first one. This connection between two entities is referred to as an entity relationship. There are three types of relationships you might encounter in the wild: a one-to-one, a one-to-many, and a many-to-many relationship. Each one serves its own purpose and benefit when it comes to data integrity. Let's start by looking at a one-to-many relationship. A one-to-many relationship is when you have one instance of a parent entity that points to many instances of some child entity. Consider a student and the vehicles that they can park on campus that they have to register with the university. We should always have one record of that student, but they could register as many vehicles as they want, so we could have many records of a vehicle that point to one student. So let's talk about how we would enforce that relationship using the Room library. Here we have a vehicle entity that's already created with two properties, a vehicle ID and a vehicle type. Now this doesn't yet reference any students, so let's add a new property called owner ID, and it has to be the same data type as student ID in our other entity. Now this may seem fine because we can insert into the vehicle table with a valid owner ID and then query for vehicles by student, but nothing is actually enforced at the database level yet. I could insert into our vehicle table with an invalid owner ID and the database would have no idea. In order to create an actual link between these two entities, we need to create something called a foreign key reference. In Room, we add those within the entity annotation. We define our foreign keys, which is an array, but here we're just going to give it one foreign key. Within that, we need to tell it what entity we're referencing. In this case, it's student. We need to give it the parent columns to reference. Now, parent columns refer to the parent entity, which in this case is student, so the parent columns should be student ID. And then we tell it what child columns should match those parent columns. Again, the entity we're working with is the child entity, so that column would be owner ID. And now we have an actual link within the SQLite database to ensure that we only add vehicles with valid student IDs. If we try to pass some owner ID that does not exist in the student table, Room will disallow us to insert this. So now we understand a scenario where we want to use a one-to-many relationship and how to create one and enforce it at the database level using Room. Next, we need to understand how to query a one-to-many relationship. Let's say we want to get a list of every student and with them a list of all the vehicles they've registered on campus. You might be thinking that we have to write some complicated SQL and use a join statement to make this all work, but Room actually takes care of all of that for us. We don't have to write any additional SQL than we would to just request a list of students. So let's look at what's required of us in order to query this relationship. Here we can create a new data class called student with vehicles. It's going to have a student property and a list of vehicles that belong to the student. Now we need to come back to this class in a moment. We're not completely done with it. But let's start here. This is what we want to request from the database, every student and the vehicles that they own. Next, we're going to go into our university database access object and create a new function. This function will be called fetch students with vehicles. It's going to return us a live data so we can get updated of the response and a list of students with vehicles. On top of this function, we need two annotations. The first one is the query annotation, and we're going to add the SQL to fetch every row from the student table because we want all students and their vehicles. Notice how we didn't leave any connection to the vehicle table yet. We also need the transaction annotation because behind the scenes, Room is going to run two SQL queries, and these need to run in a database transaction. Going back to our student with vehicles data class, we need to modify these two properties with some additional annotations. First, we put the @embedded annotation on top of the student property. That's because in order for Room to query for this data class, it needs to know how to map each column from student into this student property. And we do that through the embedded annotation, much like the embedded properties that we looked at before. On top of vehicles, we give it the @relation annotation because we want to explain the relationship between vehicles and students. This annotation is going to have two properties inside. The parent column to reference, which is student ID inside the student table, and then the entity column that should match. And this is going to be owner ID because that's what we called the column in the vehicle table. And now with this, Room will be able to query the entire database for the students and the vehicles associated with them. The syntax we just looked at is going to be very similar to the syntax we have to write for the remaining database relationships. Before we dive into those, I thought it would be good to stop and make sure we understand why we had to write the code that we just did. Why did we need the embedded annotation on student? What was the @relation annotation actually doing? In order to understand that, we actually have to dive into the generated code from the Room library. Now, if you've worked with Android databases for a long time, and the SQLite Open Helper and cursor loaders, you may be familiar with some of this syntax. If you haven't, it's not a big deal. Don't be intimidated by the large amount of code on the screen. We're going to highlight specific lines in that generated code just to help you understand what Room is actually doing, which may influence how you write these queries and understanding how they're performing in the first place. Okay, here we are in one of the generated classes from Room. This one is universitydio_impl.java. This is the actual implementation of our database access object, the interface we were just working with. Like I said, there's a lot of code on here. We don't need to understand it line by line. But we will notice here is our fetchStudentsWithVehicles method, and we can see from the first line the SQL query that's going to run. Select star from student. That's the SQL that we wrote. A little further down, we might notice some other database boilerplate, but here we can see it pulling all of the columns from the student table. It was able to do this thanks to the embedded annotation that we just added. To understand what happened with the relation annotation, we notice further down this long generated method name for fetch relationship vehicle blah blah blah. If we scroll down to see what that method is doing, something might stand out thanks to the syntax highlighting another SQL query that's being run. Here, we're selecting every property from vehicle where the owner ID is inside the list of student IDs fetched from our last query. This is the reason we needed the @transaction annotation, because we're running two database queries here. We're first getting every student, and then we're getting every vehicle that belongs to one of those students. And then further down in this generated code, the Room library is going to take the results from both of those queries and map those together into those nice data classes with students and a list of vehicles that we saw earlier. In reality, it's not often that you look at the generated code for a library like Room. I almost never do. In this case, I thought it would be helpful so you would understand why we added all of the different annotations that we did. How is the relation annotation actually working? And why did we need the transaction annotation when it felt like we were running just one query? Hopefully this helps you understand a little bit of what Room is doing behind the scenes, and now we can begin to talk about the other database relationships. Now that you understand a one-to-many relationship, let's give a brief nod to a one-to-one relationship. These are a little tricky database relation to understand. It's when you have exactly one instance of a parent entity and one instance of a child entity. Your first question may be, why would I do this? If I have one instance of this and one instance of that, why not put them in the same table? Well, let's consider a scenario like a student and their university application if they can only apply once. Part of the reason you might want to store this in separate tables is for data size concerns. Maybe there's a lot of data regarding the application, and I don't want to pull all of that data when I really just need the student's basic information. There's a chance you might want to do this for security concerns as well. Maybe you only want certain people to have access to their university application, so you put that in a separate database, just have a link back to student. Technically, one-to-one relationships can be difficult to achieve, because we can't always ensure that we insert to two tables at the same time. The best we can do is take that second child instance and make sure we have only one reference to the parent. Let's look at how we can do that in Room. Now that we're familiar with the syntax, let's look at our application entity. Down below, we have a data class with three properties: an application ID, the student ID for the student that's applying, and some application text about why they belong at this university. At the top, we define our foreign keys, pointing to the student entity and saying that the parent column student ID must match the student ID of this table. So far, this looks exactly like the one-to-many relationship that we just created. So how do we go a step further and ensure that we only have one application to one student? We do this by creating a unique index within the application entity. To create that index, we'll go below the foreign keys inside our entity annotation and define any indices that we want. Here, we're going to have one index, and the value of the columns in this index is just going to be our student ID. And then the kicker will be to add the unique property and make that true. And now this is going to enforce at a database level that any given student ID can only appear in the application table once. So no student can have two applications. Let's move into our student with application class. This is going to look very similar to our student with vehicles class, where we have a student with the embedded annotation and an application with a relation annotation explaining how that relationship works. Notice here how we're looking for one application instance and not a list like we were before. Then we go inside our DAO and we notice we can create a new method that looks exactly like the one before. We have a query annotation selecting every student and a transaction annotation because it's still going to run two queries behind the scenes. One to request all students, one to request all applications, and then mash the two of those together into our nice student with application class. Something you should keep in mind about the query we just wrote was that inside our student with application class, we referenced a non-nullable application. This means that our query assumes every student record has a valid application record associated with it. If this isn't the case, Room is going to fail when it runs this query because it won't have an application to put inside the response. We have two options here. Number one, we can make our application reference nullable if we don't care whether or not a student has an application. Another option is to make sure we only query for students who do have an application record associated with them. You can decide what you think is best. Let's move on to our last relationship, which is a many-to-many relationship. This is when you have many instances of a parent entity and many instances of a child entity. Keeping with the theme of a university database, an example here would be students and classes. A student can be taking more than one class, and a class can have more than one student. Now let's dive into the code and understand how to organize and structure this relationship using Room. Here we have the student entity that we've already created. Below this, we have a new entity that we call class. It has a primary key and a class name, which is going to be history, math, science, whatever the user may be taking. Now, in order to make sure these two entities can reference each other, it's not enough to add a field onto one of them and point it to the other. That won't allow us to put many-to-many relationships. Instead, we need to create something called a joining table. We do that by creating a new entity. Here, we can call it class enrollments. Inside of class enrollments, we'll have two properties, a student ID and a class ID. This will allow us to make the jump between the two entities by taking a student, getting its ID, finding that student ID inside class enrollments, and then getting the class ID, and finally mapping that to the class table itself. That's why this is called a joining table. Now, since this is a new table, it also needs the entity annotation, just like anything else. Inside the entity annotation, we also need to define a primary key for this class. We don't want to allow the same student to take the same class twice, so we're going to make the combination of student ID and class ID a composite primary key. And to ensure that we only use a valid student ID and a valid class ID, we need to create the same foreign key relationships that we've already looked at. One is going to point to the student table, point to the student entity, make sure the student ID matches the student ID from this entity, and then create a foreign key that points to class and make sure that the class ID in that table matches the class ID in this table. Next, we can look at how to query this type of relationship in Room. This is another data class called Student with Classes. It looks very similar to the data class response types that we made earlier. We have an embedded property for student and a list of classes with a relation annotation defining which columns help relate student and class. Unlike our one-to-many or one-to-one relationships, though, class and student aren't directly linked, we have to go through the joining table that we made. In this case, we need to tell room what entity these two are associated by. We do that by creating a junction and giving a value of that joining table entity. Here, it's class enrollments. Once we've done this, room will be able to link all three tables together and pull any student and their list of classes. When it comes to querying for this data, we can go inside our university DAO and see that we've made a new method called fetchStudentsWithClasses, which looks identical to the ones before. We still need the query annotation, and we still need the transaction annotation because this runs two queries behind the scenes. One to select everything from student, and another to select everything from class that maps to one of those students. If you want to see what these queries look like, you can dive into the same generated code that we did earlier and look for similar method names. And that's everything for the different types of database relationships you might work with in Room. I hope you learned a lot from this walkthrough, understanding at a fundamental level why database relationships are important, a quick solution to this problem using embedded properties, and then 3 different types of database relationships: how to create them, how to enforce them at a database layer, and then how to query each of these relationships. If you have any questions or want to learn more about the Room library, please let me know in the comments below. Thank you.